Today's lesson is a very short lesson on tides. They're not too difficult. Tides are the daily rise and fall of ocean water, mainly due to the moon's gravity, but the sun's gravity also fits in with the kind of special tides that we'll talk about after I explain the main ones. And I'll show this in class with the demonstration with the globe too, to make sure that you understand it. So we start off with the basic ones. The moon has gravity. We know this. The moon's gravity pulls the water in the oceans towards it, making a high tide. It also pulls the earth a little bit towards it, which then leaves some of the water behind because it's a little bit farther, so there's not as much gravity. So we also have a high tide on the other side of the earth, from where the moon is. On the two kind of 90 degrees from that, we have a low tide and a low tide. So think of it like this. Wherever the moon is, there is a high tide because it pulls water towards it. There is also a high tide on the exact opposite side of the earth than the moon. 90 degrees from that, there's going to be a low tide because that's where the water came from. Okay, the water rushed over that way. So, wherever the moon is, there's a high tide. Exact opposite side of the earth, there's another high tide. There's low tides at 90 degrees. Because the earth spins quickly, right, every 24 hours, and there's a high tide, two high tides, two low tides, take 24 hours, divide it by 4, and you get there is a tide change every 6 hours and 12.5 minutes. Because remember, the moon also moves too. So it's not exactly 6 hours, it's 6 hours, 12.5 minutes. So again, wherever the moon is, there's a high tide, there's another high tide on the exact opposite side of the earth. Well, now we have our two special tides, because the sun also has gravity. So we need to factor the sun into it. The first special tide is called a spring tide. That's when the sun is pulling the same direction as the moon is. So the sun has gravity, so the sun is pulling water towards it. The moon also has gravity, and if it's in a line with the sun, it's pulling more water towards it, and we're going to get a really high tide. Correspondingly, the low tide at the 90 degrees from it is going to be really, really low. So a spring tide is the highest high tide and the lowest low tide. The highest high where on the side that's in a line and on the opposite side. So how often is this going to happen? It's going to be 2 times a lunar month. Okay, I'm going to put month here. I guess I should put lunar month because it's not exactly a month. So 2 times a lunar month. What phases will that be? In this picture, what phase is this? When the moon is between the sun and the earth? Okay, we've gone through our moon phases. Moon is between. That's a new moon. Will we also have a spring tide if the moon's over here? Sure. The sun will pull this way, the moon will pull this way, and we'd have a spring tide that way. So it's a new moon or a full moon. Both of them will give you the highest high tide and the lowest low tide. So that's going to happen twice a lunar month. Well, how high is the highest high tide and lowest low tide? The biggest one in the world is in the Bay of Fundy. It's in Nova Scotia, Canada. And it's 54 feet. So at the spring tide, it's a change of 54 feet. It's a lot of water going through. It's mainly because of the way that the ocean floor is situated or is geographically arranged around there. A huge tide. Even just the normal daily tide, it said it was something like 100 million tons of water moves in every day. It's more than all the freshwater rivers combined in the whole world. It's an amazing amount of water goes in and out of the Bay of Fundy every day. Some people have thought about putting some, not wind turbines, but water turbines underneath water and letting the water come in and then the water going out, spinning the turbines, and generating lots of energy, lots of electricity that way, because it is such a huge rise. There's also quite a few people go to watch it. Okay, it's a big tourist thing to go watch this tide because you can actually see it going pretty quickly because it's rising 54 feet in basically 6 hours. So that's the biggest one in the world. The opposite of a spring tide is a neap tide. That's when the sun and the moon are pulling at 90-degree angles. Okay, they're pulling in different directions. So the sun is going to pull some water towards it. The moon is going to pull some water towards it. So it basically evens out throughout the earth. So it's almost like there's no tide at all. So it's the lowest high tide and the highest low tide. It's basically mediocre tides. Okay, the highest high and the lowest, or the lowest high and the highest low. Well, what moon phases is that going to happen? What moon phase is this one? That is the waxing quarter. Would it also work if the moon was over here? Sure. Okay, as long as it's at 90 degrees, so it also works for the waning quarter. I think I did that oppositely. Yep, I did those oppositely. This one's the waning, that one's the waxing. Either way, it's the same, waxing and waning quarters. So how often is it going to happen? Again, it's going to be 2 times a lunar month. And that's it for tides. Okay, that was really it. Again, the tide, there's a high tide wherever the moon is, and a high tide on the exact opposite side of the earth. A spring tide is when the sun and the moon pull in a line to make a really, really high tide and correspondingly low tide. A neap tide is when the sun and the moon pull at 90-degree angles from each other, so it kind of evens out to a mediocre tide. Okay, that's it for tides. Since I have a little bit of time on this video, I thought I'd just show you the planets to scale because I thought it was kind of cool when I found these pictures. So planets to scale, we see the Earth, Venus, Mars, Mercury, and Pluto. On the next picture, now we add in the Jovian planets. So remember, these ones are the terrestrial planets, ignoring Pluto, not actually a planet, dwarf planet. Now we add in the Jovian planets. You see how much bigger they are, and the Earth is down here, and Pluto's tiny. Then, okay, what if we could zoom out even more? Now we add the Sun in. So the Sun is huge compared to them. The Earth is this one, and Pluto, I think we can't even see, right? Pluto would be down in here. So incredibly big. I also seen one where they add then like Betelgeuse to it, and everything is so small you can't even see the Earth. So it's kind of neat. So I thought I'd add that on to the lesson since the tide one was so short. And that's it.